reason would be prevent future problems through either code review or monitoring, or just maybe you run into something inadvertently and say, that's ugly. But preventative optimization is probably the easier thing for us and the more rewarding, because we know that this will never become a problem in the future because we took care of it now. So even better than responsive is proactive. And if nothing, your job will be more enjoyable, it'll be easier, people will yell at you less, and you'll feel a little better about yourself and what you're doing. Certainly that. As part of it, you can train people to write better SQL. You can train developers, other DBAs, architects to write better SQL so that they're going to do their jobs better and make your life easier as well. Do more with less. This is definitely one area we can do more with less. A better written query will simply take less CPU, less reads, less writes. It's literally just better. And that is everything that any executive wants to hear is you're doing more with less, you're saving money. And everyone loves that, and it's good for you too. And, you know, again, save company money. And last but not least, it's fun. It's fun. So hopefully you enjoy it, because I think it's really fun at least. If you become crazy for that, that's okay. So, where does bad SQL come from? And this actually helps us identify how to fix bad SQL too. Developers, I love developers. We have great developers in my company, but since you write a majority of, here's developers? Any DBAs here? Mostly developers. Nothing against, we have great developers I work with, but since you write a majority of the code, obviously a majority of the problems are going to be written by developers. And developer SQL tends to look different from the SQL that people write. We'll talk about it a little more later. A little more dangerous than developer SQL is bad DBA SQL, because DBAs think they know what they're doing. That makes us really dangerous. And so when we write bad SQL, we write complicated bad SQL. The SQL people look at and review and say, it's probably good, right? And it's not always. So even more dangerous is DBA SQL. Time is a huge one. Things change over time. Data gets added and deleted. New schema, new tables, new stored procs, things get added. You upgrade SQL Server. Every time you upgrade SQL Server, a cumulative update, a service pack, a new version, things change. The optimizer changes. The way the engine work changes. Reporting services, analysis services, everything changes. Any hardware and software changes can easily change how you work. If you upgrade your software, Exchange, SharePoint, if you upgrade anything, who knows what will happen behind the scenes. So be ready that anything that changes can potentially cause problems. Clustering changes. If you run in cluster, who knows what changing the cluster and upgrading the cluster might do to you, so beware. Application usage. One day people are hitting certain tables heavily, the next day the applications change, other tables are being hit heavily. So changes in how your application you do, and of course bugs. Bugs are inevitable. Be looking out for them, but they're obviously the cause of bad SQL. Generated SQL, we'll talk about later. This is the stuff that nobody writes. A machine writes it, like Link or in Hibernate or something like that. And when machines write SQL, it can get really scary. And we'll talk about it a little bit more later. And non-technical folks. I'm not sure which is more dangerous, the DBA or the non-technical folk, but if you have marketing guys or sales guys writing SQL, beware. I wouldn't recommend it, because you never know what will happen. And so we have a lot of tools available to us in order to deal with this stuff. First and most obvious is the profiler. You can go in while something's running and do a trace and see exactly what's going on in the background. What SQL is running, the reads, the writes, CPU, duration, everything. That's your foremost in debugging tools. Dynamic management views. I have a whole nother talk on dynamic management views. You can download it from SQLSaturday.com. It gives lots and lots of awesome queries you can run and take a look in the background how things work. These are a gift from Microsoft. They're awesome. If you haven't used them, play with them and learn them, because they're extremely, extremely useful. Execution plans. This tells you exactly how your query was executed. It tells you, was it a scan or was it a seek? Was it a merge or a hash join? How did the query get from beginning to end? And that kind of can tell you the symptoms of what might be a problem. A lot of settings in SQL Server. Statistics can be turned on to show you the reads and the writes and the scans. Time tells you the exact milliseconds things took to run. XML. You can turn profile on and get more data than you need probably. So you may not need all this, but a lot of options available in T-SQL to get more information about the query as you execute it. And then of course you have all of your server and instance stats, your disks, your waits, your locking, your deadlocking, CPU, memory, you name it. All that's available from Perfmon through DMVs or through your trusty admins who may capture all that information for you. And so if you're not really sure what's causing a problem, this might tell you, or this might just tell you there's a problem because something terrible is going on. Either way, it's a good indicator of potentially how to fix something. And last but not least, there's lots of monitoring tools out there. If you saw all the vendor tables out there, you have Confio, you have Redgate, you have lots of companies selling cool tools. You might use some in-house. These are an opportunity for you to buy a tool that may help you. Just make sure the tool you're buying or using fits what your company does. Not every tool is right for every application, and just buying an app and installing it will not necessarily solve your problems, but even create problems depending on how its usage is. So definitely test ahead of time a lot before installing vendor software. Always. Always. So, an important rule in DBA land is it depends. Is one index better than another? Is a certain join better than another? Should I use a temp table or a table variable? It depends, it depends, it depends. Some things are hard and fast and true all the time. Many things in SQL Server depend. They change, they vary. It depends on what database you're in, what table you're on, what index you're using, who's running it. And so, it depends, it depends, it depends, it depends a lot. So, always keep that in mind. You don't have to give an always and never answer to every question in the world. Keep in mind that things change. And so, before we dive in, just a few notes and execution plans. I'm not going to give you tons of execution plan details. I'm trying to keep this a little high level. If you have any very detailed questions, we can talk afterwards and chat about them. Execution plans tell us a lot. Generally, when you're reviewing an execution plan for the first time, you're looking for the operations that have the highest cost. What's the most expensive piece of this query? What is taking up the 95% of it, and what's the rest? That 95% is probably where your problem is. So always keep an eye out for the biggest problem. Many times it'll be the fat pipe. You have all these little scans and seeks, and they're all coming together. You have a huge fat pipe there of millions of rows, and everything else is small. That could very well be the source of your problem. If you're reading too much data, if you're writing too much data at one time, that could very well be the indicator of a problem. And so always check the actual and estimated rows returned. If they're way off, if it thinks you have 1 billion rows coming back and you have 10, something's wrong somewhere. It's using the wrong index, or maybe something else is going on. Take a little deeper. We'll have some examples later of this. And try to reduce the data size as early as possible. If you have 10 rows at the end and 1 million rows in the beginning, cut it down, group it early. Especially in stored procs, where you have lots and lots of procedures. Just get your data set small, then it's easy to manipulate and work with. If you bring millions of rows all the way through, it's expensive. Check the properties. If you right-click on any step of an execution plan, you have tons of information. If you're not sure what's going on, hover over it, right-click, go to properties, tons of information. And things to investigate. Cluster index scan basically means you're going all the way through the table, checking every single row for something. That's probably a problem. Index scans, same idea. If you're going all the way through a table, it's dangerous. Key lookups mean that you went back to the base table to grab data that it couldn't find already in your index. Maybe indicative of a problem. And if it's the source of a lot of pain and reads, you may want to add some included columns to your index. And lastly, warnings. As we all know in Microsoft world, exclamation marks are bad. We all know that. And so if you see exclamation marks in your execution plans, hover over it, check it out, see what it is. It may or may not be important, but it's worth checking out because it's an exclamation mark. Those are important. And last but not least, this is a free tool. I like it. You can pay for a big version of it, but SQL Century Plan Explorer is an awesome program. You can download it for free as a trial, sort of. It's great. You can look at your execution plan full screen. It's big, it's pretty, it's better laid out, and I like it a lot. And I would highly recommend downloading it and checking it out, at least for your own personal usage, if nothing else, because it's great, and free things are also wonderful. So, moving right into it, the source of a lot of our pain, the source of a lot of our trouble that we'll have in queries will be in your joins and your where clauses. This is how we constrain a query and bring it down to the data set that we want. And so, we want to pay a lot of attention to these. Pretty much how you figure your where clause out will determine how your query executes and how you're doing it. And so only get as much data as you need and sort it out as early as possible. Your where clause is everything. Make sure that that where clause gets only what you need and nothing more. If you're reusing data a lot, consider temporary storage. A table variable, a temp table, or so on. But even consider storing really important, aggregated, complicated data somewhere in your database so you can get it later. Don't reinvent the wheel over and over. If you see yourself doing the same things over and over and over and over and over, we know something's wrong. Maybe we should find a way to solve that. It's not worth the CPU cycles to repeat the world over and over. Typically, equality is better than inequality. A between is better than an in's better than not in. And an equal sign is much better than not equals. If you can say, do something where status equals 1, that is way better than saying where status doesn't equal 2, 3, 4, 5, 6. The optimizer might figure out what you mean, it might be smart, or it might just flop. And so equality, when possible, be as specific as you can. And huge important one if you have where clause, the string. Always check if you can like this, because when you do something like this, you're providing the beginning of the string, and it can use an index for it. If you put a % sign at the beginning of your string, it scans the whole table. There's no way to stop it. If you put a % in front, your table scanning it will stink. Guaranteed stinkage. So try to avoid it at all costs. Even multiple queries not having that are better than one that does. And again, it sounds kind of rude socially. Be exclusive. Cut your data size down. It's really important. An and will typically reduce the data set because you're saying this, and SQL Server can work with that. When you use an or, it's going to check each one individually and figure things out for you. So try to be exclusive. So I have an example over here, and that didn't do what I thought it would do. That's okay. So we have an example here of joins. These are all using AdventureWorks. So if you have AdventureWorks, you can do all these at home if you'd like. This is a very simple query here. All it is a select distinct, 2 tables, and it's joining on 2 different columns. Looks pretty simple, right? Should probably run pretty fast, right? And it's taking a while. It might take a few minutes. Maybe hopefully just 30 seconds. My laptop's crying right now if I did this. It's a good chance for me to get some water. Yes?
Can you just repeat what you said about strings again?
Sure, I would love to. While it's finishing executing, I'll go back here. Strings, in general, we're not talking about full text indexing here, but a lot of times you're looking for a wildcard, like is something like something. You'll have % to do it. This will be like any string that starts in text and ends in whatever. This is pretty quick. You can use the index for the first 4 letters and kind of zoom in on that word. If you put a % in the beginning, though, it has no idea what your string starts in. It's going to scan the whole table. Every time, no fail. There's no way to fix this. If you do a like with a % in front, you're guaranteed a table scan. It's going to check every single row, and it's going to be painfully slow. Sound good?
Yeah.
All right. So back over here, our query finished. Took 17 painful seconds where my laptop hated me. And the reason why it was slow is this join has an or in it. Now you think, oh, can't I just figure it out? But it isn't really that good at that. And so basically it's going to go in circles, checking each one, or. And it's painful. And one of the rewrites we can do for this that is kind of nice is all I'm doing here is taking the 2 clauses in the join there and separating them out. So now we have select same stuff from the same tables with one join here on product ID, the one from up here, union it with this down here. It's the other half of it, that row GUID from here. This query looks a little longer, making you think it's going to run poorer, and it's got 2 selects in the main table, but the clauses are simpler now. Just one join clause, each one, and if I hit F5, it's done. 0 seconds, my laptop loves me. And so always consider if you have a very complicated statement, separating it out, because the optimizer may not be smart enough to figure out what it is you're trying to do, and it may just be scanning over and over to try to sort it out. So sometimes simple is better. We're going to jump back to the presentation. That was joins and where clauses. So this is kind of a little thing that happens in the background, and it can be painful, and we don't always notice it. And this is conversions. Your data types are really important, and so are what you put in those where clauses in your join. Keep them clean. Try to avoid putting functions in there. Try to avoid putting date diffs and date adds and stuff like that in, because the more you operate on your columns while you're joining or where clausing, the harder it is for the optimizer to figure out what you're doing. And in the end, it makes it scanning the whole table because it can't figure out what's going on. And I'll have an example for this in a sec. If you're applying functions anywhere, try to apply them to a scalar. If you're saying, where a date is equal to a scalar, apply all that crap you want to do to the scalar and not to your actual column in the table. Because again, it may not be able to figure it out on the fly what it is you're trying to do, and it may be very inefficient. Again, move all the operations onto your scalar. Any kind of functions you're doing, even math functions, date functions, anything, put it onto a scalar variable. Even if it's really ugly, your scalar has a whole pile of junk around it. It's better than having it in the column from your table. And if nothing else, consider changing how your app works or how the column is used in your database to make it so you can operate on the scalar. Because again, operating on the column is going to be a mess. And beware comparing data types that are different. A lot of times we'll compare an nvarchar and a varchar, or an int and a tiny int, or worse, like an int and a varchar. If you compare different data types, SQL Server may figure it out quickly, or it may suck. And there's no guarantee anywhere as to how it's going to work. And so I have an example here. I love examples of what happens when this goes right and when this goes wrong. This is a very common example. Anybody here work with phone numbers a lot? People enter phone numbers in the GUI, and they'll enter in dashes and parentheses and plus signs and Lord knows what. And then your database, you got to store it somehow. And so who knows how it's being stored. So in this example from AdventureWorks, it's stored in the database as a number potentially, but who knows what the user enters. So I created a little function. This will pull all the non-digits out of your phone number, so it'll be beautiful. And so what we have here is we're just doing some selecting, some joining, and we're saying, hey, take the phone number from the database, pull all the non-digits out of it, and see where it's equal to this. Great. It'll be all the same. It'll run great, right? It might. So we run it. Takes a little longer than I wanted. Returns some stuff. If you look at the execution plan, what do you see? You see some scans. Index scan, which basically means it didn't try. It just went right through the tables, beginning to end, until it found what it wanted, which is pretty lame. And the problem here is that we applied a function to the column from the table. And so it can't figure that. It has to apply this function to every row of the table, because it doesn't know how to otherwise figure out what it is. And that's painful. You know what? You want to keep this clean. You want to say where phone.phone number equals something. You don't something ugly. So we'll scroll down a bit here. And one quick fix is let's just make it so we don't have to do that. The database will have a number. We'll input a number, and life will be good. So if we do that, it's really fast. Assuming your database can tolerate that, you'll see we have a seek and a seek, and it executes really quickly. That's nice. This is unacceptable, though. Kind of a dirty solution, which does work, but it's dirty, would be if you need speed badly. You can add a column for the phone number cleaned up. So you have your column with your phone number with all the dashes and pluses and garbage. Add a column. It's a clean phone number. So we'll alter the table and add a column. And then we'll update it and put in a cleaned up version of our phone number, which may take a little while. And of course put an index on it. That way we can search quickly on it. It sucks, it requires extra storage, but it's quick. And so now we come down here and we say, we'll select from our table where the phone number clean is equal to garbage in my scalar. And this is fine. It'll take the scalar, do whatever it has to do with it, no problem. It'll do that first before anything else. We hit F5 here, runs super fast, returns the row we want. And again, we have a seek, we have a seek. Looks a little messier than before, but it's pretty clean and it's pretty fast. I'll just undo what I just did for future use because we don't really keep this in here. And one last example would be if the input's going to be messy, but your database can be clean. If you can store your numbers clean, this counts for phone numbers, socias, whatever, credit card numbers. If you can keep the database clean, maybe even have some kind of display format you apply to it or something, then you can apply this over here and run it like this, and it should run relatively quickly. Again, finishes in no time. You get a seek, which is great. You get a seek, which is great. You notice some constant scans here. All constant scan or compute scalar is basically just it's going through and doing simple math. And for a computer, simple math is fast. Even really complicated looking things in your scalar is just math. And it's way faster at that than I am. So trust it with math. It's very good at it. And so the whole goal of all these examples basically is whatever you're doing here, whatever your joins are, your where clauses, keep the column clean and try to apply whatever stuff you're going to apply to the scalar. And one more example here would be implicit conversion. This is the sneakier one that you don't see necessarily. Implicit conversion is when you do something like this. So select some stuff in human resources, employee, where the ID number is equal to a number. Makes perfect sense. You run it. Takes a little long to run, 2 seconds, which is a lot in DBA land. The execution plan, it's a scan and a keylookup. Kind of lame, a scan. It's a number, right? But if you actually look at it, I can't really hover over it, it's actually a varchar. If you actually went to the database and you looked at human resources.employee, national ID number, it's actually a string. And it wasn't obvious. Let's say we just change our input to a string. Do nothing else different. Just change it to a string. Everything else is the same. You run this. It runs really fast. And you look over the execution plan, and it went to a seek. And if you actually go back to that first one, you were to run it, if you were to hover over the scan here, you see a convert implicit. This is SQL Server's very, very subtle way of telling you that you used the wrong data type and that it's converting on the fly. And It's better than if you would have the functions and garbage on it above, but it's still a scan, it still stinks, it's still slow, we should avoid it. So now that I've beaten all this into the ground with data types and functions and keeping things clean, we'll jump back for a little more. Sure, I love questions.
Does it matter if you're putting in a number and seeking a character string, or if you're putting in a character and seeking a number string?
Guess what? Guess what I'm going to say?
No.
It depends. Thank you.
Yeah.
Now, the best answer to your question is you should try to keep them the same. Well, the way SQL Server will actually work is it'll upcast. It'll take whatever the smaller data type is and try to bring it up to the next level. And so if the int is on the right and the character's on the left, it'll try to bring the int up to a character, probably. It'll try to bring a tiny int to an int. It'll try to bring a varchar to an varchar. It may work. It may not work. It's best to avoid it altogether because it depends, and you don't want to take the risk. You don't want to risk your production software with an it depends. You want to be like, yes, this is correct. If the boss asks you how it's going to perform, you say it depends. You should probably be fixing your resume up a bit because that may depend too. So it's one of those things. A big thing here is especially a big thing for developers because databases are different than code. We all acknowledge that. And when you write code, it's different than when you work with a database. And so SQL Server is optimized in every way for set-based operations. You want to update a bunch of rows from a table. You want to insert a bunch of rows, delete a bunch of rows, select a pile of data. You do not want to loop through one by one, row by agonizing row. They call it R-bar. You don't want to rebar, whatever you want to call it. You don't want to do that. It's bad, it's slow. This is one of those things that almost always will give you trouble. Avoid cursors, avoid loops, avoid go-tos, avoid whiles, unless absolutely possible. What are the reasons why you might need to do that? If you're outside of the current database, you may have to do it one by one to get access to the database. If you have small data sets, consistently small, it might be okay because iterating one or two rows is no biggie. But again, will that data set always be small? Well, I don't know, it depends. So when you must execute stored procs, obviously I can't throw a stored proc into a where clause. If you can do that, let me know. I would love to see that. Sure to be ugly. And maybe your database is too fast and you want to just slow it down a bit. But in general, the real point here is that and I have an example for this in a sec. Iterative approaches will almost always be slower in a database than a set-based operation. So even if it's ugly, the set-based operation is probably better. Watch out for stuff that happens in code. Obviously if you see a while loop in SQL code, you can do something with it, but many times you may have a while loop in your C# code that has a database call in it. So you look at your trace, you'll be like, oh, there's tons of database calls, they all take 1 millisecond. Woo! But there's a million of them. A million times a millisecond is kind of shitty. So you don't want that. You don't want that at all. So keep an eye out for what might not be obvious, and that you may have iteration in code that's calling the database from there. Alternatives can include CTEs, common table expressions. I'll have some examples of those in a bit. Recursion, functions, almost anything can be used to kind of fix up the row-by-row approach. And it's especially true for when you have row numbering and grouping and partitioning and ordering, keeping track of primary keys, that kind of stuff, because it can get ugly. And a lot of the more traditional approaches in older versions of SQL Server where get into a while loop and do it over and over to get your information you need. And you don't have to do that anymore. From 05 on, there's a lot of great solutions, and from 08 on, there's even more. Another key thing is that a set-based operation happens all at once. You do it once, you're done. If you have a while loop and you're going through over and over and over checking stuff, it may not do something every time through, but it's still cycling through a loop. Even if you do nothing, it's still cycling through a loop, and it's wasting CPU cycle. So that set-based operation happens, it's done, and move on with life. So here's an example. It's a very simple example. I basically have this ID here. I want to do this 100 times. I'll just update a table. I want to give some people some more vacation hours. Woohoo! More vacation hours. And I don't want to do it if they have 200. It's too many. So very simple. While loop. I'm going to do it 100 times. Increment the ID at the end. Otherwise, it'll be an infinite loop. My laptop will hate me. And go. And then at the end, we'll see what happens. So I select this and hit F5. And look over the messages. It's filling up really fast. It's working. It's working. It's done. There's a lot of stuff here. I don't feel like scrolling through it all. Execution plan, hey! 0%. Oops, I just went over it. Execution plan, 0%, 1%, 1%. Woohoo! It's great, right? But it looks nice. If you actually hover over it, the subtree cost is pretty low. It looks pretty clean. The reads are pretty low over here in general. But you did it 100 times. And so I'll use subtree cost as an example a lot. You should look at everything when you're optimized. I'll use subtree here because it's simple. So we scroll over one of these 1% here, over 100 scrolls through, 0.01. It's pretty cool, right? But multiply by 100, a little bit more. Let's say we just rewrote it and said, hey, I'll hit table, add 4 to the vacation hours, just put those pieces of the increment into the where clause. We run this now, and it finishes super fast, and you have one execution plan, and it took about the amount of effort as 2 iterations through the loop. And so again, if you're only doing 1 or 2 updates, a very, very small amount of data, iteration is probably okay. But will you always be operating on a few rows? Yeah, I don't know, it depends. So you don't want to risk that. CTEs are really cool. Something we often do are row numbers. We want to say, hey, I want to partition this data and then grab the first record of each sub-data set, which traditionally meant lots of sub-selects, lots of ugly SQL, lots of code that will make me shudder. So, to get the information here, let's say I just want to get the row numbers. So we're going to partition it by schema and do a little bit of ordering by here. So if I run this, it's great, you get some data, and it's separating it by schema and ordering it, and you have all your numbers here, and it's great. Let's say I want the first change, though, for each schema object. Well, the first thing you think is, oh, just put the row number in the where clause and run it. And if you run this, you get an error. An intentional error, but an error because windowing functions can appear in the where clause. There's a lot of cool windowing functions out there. Row number is a common one. You can't put it in the where clause, though. If you want to find out, like, only where equals 1, you can't throw it in the where clause. But what you can do, put in a CTE. Is anybody not familiar with CTEs here? We're all relatively familiar? Okay. Very quickly, a CTE is data structure. It's all it is. Look at the query here, this select stuff from a table. All I'm doing is putting it inside of here. And so basically, the syntax is with, and then the name of your CTE, whatever it is, as, and in parentheses, you put your query. So this query here is exactly the same as the one up here. But when you're finished with this CTE, you can now select from it and say, oh, select where row ID equals 1. And so now we're actually going to grab from here, very simply, almost at the where clause above, where row number is 1. It runs pretty quickly, and you'll see that the only data here is that for row number 1. And so I know I kind of gave a very quick intro to CTEs there, it took about 30 seconds, but it's one of many examples of how you get data very quickly without iteration. Another very, very common example of iteration that was always done in SQL 2000 was, hey, let's say you insert 100 rows into a table, and then you want to get back that identity that you just inserted so you can do other stuff with it. Well, there's no easy way to do it. So what you would traditionally do is you would get a while loop, and you would insert one by one, and then pull back your scope identity, and it's painful. Here's an example here. I declare this temp products table, and I'll insert into it some data, and the scope identity example is literally, you're in a while loop, one by one, getting scope identities. It's slow, it's painful. SQL Server now has output, you can do output clause. And so in between your insert, or your update, or your delete, you can just throw in an output. And so I have this temp table up here, temp products. I insert a bunch of data, but I output that primary key in the name into my temp table right in the middle of this. Then I select my data to insert, where clause, whatever, and I select from it. And what it basically does is it will insert the data just like I wanted, and then it'll select it back out for me. I got it in the table variable, it's there. And this is fast. If you went through in a while loop and did it one by one, grabbing the scope identity for your last identity, one at a time, it's going to be slow, it's going to be painful, and it's not going to look pretty. I'll have to do a bit of cleanup in the data I just created. Again, all this is available on SQL Saturday site, so you can come back and play with this later all you want. All right, we're going to jump back now. Here's another thing that happens when you make lots and lots of SQL. Encapsulation, the thing that everyone says is great in code, is dangerous in the database. You build objects over time, then you build more objects to call them, and more objects that have called them. Has anybody ever been to dbareactions.tumblr.net? If you've never been there before, I recommend going to it. I do have internet here. I'm going to try to make this work. Let's see if we have internet. It's going to crash my computer. So encapsulation is basically when you have functions calling views, that call stored procs, that call more things. And DBA reactions just has lots of funny things about stuff that happens over the course of the life of DBA. And this is what I think of when I think of encapsulation. You just keep trying to investigate a query, and you're just going through tunnel after tunnel after tunnel, going in circles, goes on forever. It's kind of like that. And in database land, it's inefficient. So basically, the reuse of tables and views and nesting them gets painful because you start losing an idea of what's going on there. And it might be efficient, but you may have to get the data a whole bunch of times in a row, and you won't realize why. And I have a great example of it in a moment. So your where clause needs to apply early on. I was saying before, be exclusive. Get the data and cut it down early. When you have lots and lots of views, getting lots of tables, it becomes really hard to do that. And your goal is to cut the data set early. If you have views, calling views, calling views, where does your where clause go? On this view? On this view? The third one? I don't know. It can go anywhere. It also becomes more readable because you're selecting star from a few views joined together. But if those views have more views and functions and things inside of them, you actually make maintainability and complexity much, much higher without even realizing it looks clean, but it performs like crap. And you don't really notice it until it's too late. And the optimizer gets dumb. The optimizer's great, it does lots of wonderful things, but when you have too many nested objects, it just can't do its work efficiently. And it's going to try, but it may not try hard enough. It may not be able to figure it out. You want to give it all the tools it can to do its job well. Yes?
When you're trying to tear apart an encapsulation scenario, like, what tools do you have at your disposal? The only thing that I've been able to really use is like the profiler.
So once you have a query in front of you that has encapsulation, I'll be totally honest, I'll usually do it the hard way. I will go backwards.
One at a time, right? And just go through it.
I'll go through it. I'll start at the lowest level possible. I'll pull out the views or selects, and I'll insert them into the next level up, and just keep doing it. It's disgusting. It looks horrible. It takes a while, but it is the best way to solve it because you'll see everything. And tracing it helps, but realistically, just start from the top and work your way through. And I admit it's painful, but if you've gotten to that point, it's the best way to fix it. And many times your final result of fixing a big encapsulated mess may be very simple, without even realizing it. It'll be very, very simple. So this is a quick example of encapsulation. Again, this query I wrote here uses AdventureWorks, and it's very simple. Just, hey, select from a view where the first name begins with E. How much easier does it get than this?
Yeah.
It's so simple. Just give me some info about this one employee where his name begins with E, like Ed. And it's great. And you hit F5, and it goes pretty quick. You go to the execution plan, and oh my gosh, there's like tables and nested loops and seeks and stuff, and there's a lot in there. I only went to one table, right? It's one view. But if you actually were to hover over it and get some information about it, and it's not hovering, the employee is actually a little more complicated. Let's say we go over to the view here and look at humanresources.vEmployee. See what it looks like. It actually goes to a lot of tables and does a lot of stuff. And so here it is. Let's go and take a look at this view, which apparently does a lot more than I thought it did. And my laptop isn't very happy with me, but it will it'll come through in the end. I'm sure of it. All right. Anyway, I'm not going to right-click on it, I guess. Not today. Oh, there we go. This one I gave up. So here's the view. What is humanresources.vEmployee? I couldn't have told you. It looked like an employee thing that was pretty simple. But when you actually look at it, when it comes up, it's complicated. It's getting tons of stuff from like a million tables, all innered and outered and all kinds of stuff. And that's messy. And I just wanted a few things. And so let's say you took that view, you pulled it apart and figured out, oh, I want 4 columns in the end. You rip it out, take it apart, and put it back together. What you really get is this. You get 2 tables joined together. If you run it here, it's very fast. Same data, same results, and it's a lot quicker. And only hitting 2 tables. So this is where encapsulation leads. This is a simple example. I've seen production examples of tens of thousands of lines of SQL all being called all over the place. And your goal is to avoid this from happening in the first place, but if you see it, it's a good chance to optimize and fix and clean things up. Because, again, maintainability is more often than not the reason why you encapsulate, but maintainability shouldn't be at the cost of your performance. You want things to be as simple as possible, but also as maintainable as possible, and not get extra data. Because you saw some inner joins in that view, those inner joins were happening whether I wanted them or not, and they cost money. Yes?
I realize the answer to this is it depends.
Yes.
But is there a certain ideal point where you draw the line between data normalization and table joins?
I would say that it really ends up being performance in the end. You want it to be as normalized and as simple as possible. You do want it to look good. You do want your selects to look nice. And many times when you go pulling apart queries, it becomes messy. You add more joins, it looks worse. I would say performance is getting poor, and it's because of this, it's probably worth tearing it apart. If you can proactively do it in the beginning, you're saving some trouble. But it really is up to you as a developer to decide at what point is the trade-off happen. And there's some companies that are happy to throw hardware at it. Not everyone is. There are many companies that will say, you know what, we'll give you an SSD SAN and these beefy database servers and hundreds of gigs of RAM, make it happen because we want it to be simple. Not everyone does that, and so it's also your budget. That's part of it too. And so the it depends on you as to what's going to happen. I forgot to do about something earlier. These are evaluation forms. Just pass them around, please. Here's, we already have some. Anybody need some? Come on, yes.
Apart from Japan, how do you suggest we handle hierarchical tables where the nodes are not, the levels are not always the same? Basically, I have hierarchical tables like, let's say, like 12 levels, but my leaf level won't be 12th level always. How do you suggest to handle this kind of?
So basically, how to read a table where like you have an employee structure, we have managers and that kind of stuff.
Right.
I don't have an example of it here. We can talk about it a little bit later if you'd like, but a lot of times it ends up being recursion. A common table expression with recursion will allow you to jump through very quickly and traverse that tree quickly. You can do it in a table structure.
Right. City we have already tried City, but City is not always, like I would say 70% out of the 70% out of 100%. Like it works just fine, but sometimes it just kills the server when we join back to the queries. Sometimes like feels like it, and from the query execution line, what we saw that like when we join back to city, it always query the city over and over again when we join.
Okay. So I'll provide an answer, and if you want to talk more about it, we can chat afterwards about it. But when we get to that point, we have a very complicated hierarchy. I would suggest adding a few columns and putting more data in. Information that might help you traverse that faster. If you haven't indexed the right columns, consider indexing. I know I'm giving very general answers here, but it's hard to know without seeing it, what's going on. And you might be interested in actually rolling up common data. If there's certain data you're getting all the time, like how many hours of vacation does somebody have, or what's the salary for a whole department, you may want to actually roll that data up somewhere ahead of time so you have it available, either in a warehouse or just in an aggregate table. It's not normalized, but it may speed up. If you're doing the same thing over and over and over again, there's a reason to believe that maybe there's a better way to do it. And so if it answers the question, that's good. If not, find me afterwards and we'll chat so we can kind of look at it a little more specifically, because I don't want to spend too much time on one problem. So I'm going to move on now. If anybody else has any questions I haven't answered, just we'll chat at the end. We have lots of time. That's not a problem. So I'm going to jump back here now. So that's a huge area encapsulation, a lot to talk about, and I understand that I kind of cut everyone off at the end, so I apologize. But there's more. So triggers. Everyone groans when they hear about triggers. Triggers are dangerous. They're good and bad at the same time because they allow us to enforce logic in a database because it always happens. You put an update trigger, it means that every time you update your table, this trigger is going to fire. It's great for making sure something always happens, but it's dangerous because it always happens. And it's very, if you're writing triggers or working with them at all, if you're not working with triggers, you can just zone out for a few minutes. If you do work with triggers, though, or you have a lot of them, be really careful because this stuff is now happening all the time, and you may not want it to happen all the time. Mm-hmm. It's great for error checking, like raise an error if something happens. If somebody enters some bad data, raise an error, get us out of here immediately. It enforces that logic and makes it so nobody can violate it. And that's good. But again, it's more code. Order does matter. You can have a after trigger, where basically something happens like an insert or an update or a delete, and then the trigger fires. Or you can have an instead of, where you decide what to do instead of it. The order does matter. You can have both, which is complicated. You can, instead of triggers, I would recommend anything instead of triggers you have available at your disposal. I would recommend a cascade delete and update if you know it's reliable. I would recommend using constraints in the database, a check constraint or a foreign key constraint. If you have a column that should always be 0, 1, 2, or 3, you can have a check constraint for it to be 0, 1, 2, or 3. Don't make a trigger so you need to go out and check, because again, triggers can be complex. And once you begin creating triggers, you begin adding more to them, and they get more complicated. The order begins mattering. It gets crazy. So use constraints when possible. Triggers calling triggers.
Yeah.
The insert trigger calls the update trigger. The instead of update happens, the after update happens, and your mind is boggled. One trigger updates a different table. Yes.
There's a limit of 32 missed calls, right, inside a SQL Server?
By default, recursion is limited to 32.
Right.
I believe you can get around it if you want, but if you're getting to that point, that should be a warning sign that you're in trouble.
Right.
So be very, very careful too. Like, there's actually a recursive trigger setting in SQL Server. Do not turn it on unless you are 100% certain you understand everything about what you're doing, because it's dangerous stuff. You can get an update trigger that calls the same update trigger and goes in circles, and that is scary. It sounds dangerous from any standpoint. So you do not want things calling themselves unless you really, really mean it. Always check for triggers in response to mysteries. If you update a table, you get an error about some totally different table. If I update my employee table, I'm getting some error in some other table. Check the triggers, because odds are something's happening in the background. More often than not, if you do something and completely illogical things are happening, it's probably a trigger. And so again, a summary of this, I have no examples at all. Just avoid them if at all possible, and if you must use them, keep them simple as possible. The more complexity you add into them, the more you got to check them all the time. Yes?
I have this stupid example. I added a filtered index on a table, and the recursion was so bad that I actually hit that 32 recursion limit.
Wow. Recursion can be extremely powerful for certain problems, but this is not the place you want it. And again, unless you really know what you're doing, avoid triggers, avoid nested triggers, especially avoid recursive triggers, because the path you go down will be very, very scary.
The dark side.
We're going to go right past that now, because that really is the dark side, and I really do not want to go any deeper into that because it scares me. So temporary data storage is a godsend. It can be good and bad. At the same time, depending what you're doing, it depends. I say it a lot, but it's important to have that. And so different types of temporary storage out there. The first one is table variables. That's where you have your @. I'll have some examples in a sec too. So you have an @ sign and your table variable. You declare it, you put data into it. You don't have to get rid of it. It goes away on its own when you're out of scope, out of your session. They're quick, they're dirty, they don't use a lot of resources, which is kind of nice. They're good for random I/O, they're good for small volumes of data, they're good for data where you just kind of shove it in and take it out with minimal manipulation. Very, very useful for that. The alternative is temporary tables, or the # tables. These, you create them, and then you can drop them at the end. So when you create a temporary table, it goes into TempDB. You can even go into TempDB while you're working and look at it if you want to, if you can find it. They require more resources, as they're actually like a physical structure in TempDB you can look at, you can play with it, you can index it, make constraints on it, primary keys on it, whatever you want. It gives you more options for speedier access because it's a real table. It behaves very much like a real table that you create yourself and put in. I'll show you an example of a select into it in a minute, but you can select data directly into it without declaring it, which is kind of cool. I'll have an example of that. And they're very good for a lot of data manipulation. If you have a stored proc where you're taking data, insert, update, delete, you can't combine it all somehow. This really is the key to getting it to go a little faster, because the temp table will do that. You can put statistics on it, indexes on it to make it run faster. So a lot more you can do with it. It makes it more complicated, but it gives you more options at the same time. And another option too is no storage. And this is something people don't always notice, but if you're inserting into a temp table 5 times and then selecting out of it, maybe you can combine it all together into one big statement and avoid the temp table altogether. That's a key thing that might help. It may make your life complicated, but it can also help a lot if you're not getting too complex. And one other note on temporary storage: if you look in your your query execution plan, you see a work table. A work table is basically a temporary table that SQL Server created while doing all your work for you. So you may select from a table the big query, and it may actually make temporary storage on its own to use. Just a note in case you see it: it's possible that a read operation can write in its effort to try to do something more efficiently. And really important, this is one area where you want to test and experiment and verify results. Don't be afraid to try every option and see what works best, because this is an area where it depends really applies. And I cannot tell you a table converter is always best, or that a temp table is always best. Never the case. Anybody who says that is messing with you. Definitely call them on it. Call people on that when they say that kind of stuff, because they're wrong. And that is 100% wrong. Nobody should ever be saying, always use one of these, because very, very often they're going to lead you down a bad path. So here's some examples of temporary data storage in action. And so what I want to do here is I'm going to create a temp table, right, insert some data into it, insert some more data into it. I just have the subtree costs here as a reference. The reads are pretty proportional. Another insert into it, and then select out of it. So basically I'm putting data in 3 times, little different sets each time, then I'm pulling it out. So let's say I drop a table at the end, I'm a good boy. I drop my tables when I'm done. So let's say I run all this. It runs, it finishes, I get all my data back. It's great. And if you actually add up the subtree, I'm just using subtree cost again because it's easy. It's a simple number here. The reads are proportional to this in this case, so this is a good measure. 0.636 of the units of subtree cost. Just to give you an example. And the total for that select and then the final select, everything added up all together is like 6.4. Just a reference point here. So basically, if you look at the execution plan, what happened? I created my temp table, I inserted into it. You notice that when I insert to my temp table, there's a table insert here. That's expensive. There's no indexes on it, no statistics on it really. It's just throwing data in randomly. That insert's kind of expensive. So whenever you insert from, select out of, or delete from, or update a temporary storage mechanic, it's going to be a little slow. So each insert here is kind of expensive. It's like 50%, 80%. And then, at the end I select it all out, so there's no real worries, just a big table scan. But it's a little painful. So let's say we try a select into. Instead of declaring the table like I did up here, create table, you can do it on the fly. You can say select my data that I want into it, and it'll create it on the fly. The huge benefit of this is that it'll make the columns only as big as you need. If a tiny int is good enough, it'll make it a tiny int. If a varchar 147 is enough, it'll make it a varchar 147. So you may save a little bit because it's only going to make data types as large as you need on the fly. So I'll take this and run it, and just like before, I'll drop it at the end. And the execution plan, I did it all in one step with unions to make it a little simpler. It didn't save me a whole lot. It was a little faster, but not a big difference. Sometimes it can be faster. In this case, it was only a smidgen faster. So it's probably worth it, not a big difference. How about a table variable? Table variable, quick and dirty. So we declare the table variable here. Everything else is the same. I select out of it at the end. We can drop it, table variable. It'll go away on its own. Same data set comes back. A very similar execution plan. Table insert is still pretty expensive. And overall, a little cheaper, getting a little better, but still, not a huge difference. We're talking like 10% improvement here, which is not bad, but not, wild. My last example here is the do we need temporary storage at all example. And this is not always the case, but sometimes you can combine it all and save a lot of trouble. But every time you go out to disk, it's expensive. Going to the base table costs a lot. As I'm sure you all know, what's the slowest part of any server, computer, or whatever?
The disk.
Besides the user, it's the disk. It's the slowest part of the computer. They're spinning mechanical things, they're slow. Even your SAN with a billion disks, it's kind of slow. Going out to disk is slow. Doing it 3 times is expensive. Doing it once is a little better. And so let's say we made a CTE here, and we put our select inside it. This is the exact same select as before, no difference at all. So we put it all together, unit together, and then grab out the data at the end, all grouped just like before. No temp table, no table variable. So the huge thing we save here is no need to populate a temp table. Done. And the end up cost is about half of what it was originally. And again, this is an area where it depends always applies. But doing it like this will look a little more complicated. So maintainability is an issue, but it can be a lot faster. And faster, more often than not, will win out in the end, because if you can do it twice as fast, that's half as much CPU, half as much disk, half as much everything. Twice as much work will be done. And more often than not, that is a beautiful, beautiful thing. So I'm going to go quickly through this one because I kind of talked about it a bit already. I'll hit it again because it's important. You can combine SQL statements. This is especially true in stored procs where you slowly build up a lot of code over time. If you have lots of selects, lots of inserts, lots of updates, you may be able to combine them and make your life a little better. If they have similar filters, similar groupings, similar joins, put them together into one statement because that, again, hitting disk is expensive. Doing it once is better than doing it 5 times. So you can minimize your reads, always a good thing. And even a very complex select that has cases and converts and casts, in the end, might be better than having many, many selects. And I'll show you the example very quickly at the end here. Again, stored procs, this is very common in functions. We have lots of procedural T-SQL where people go in and say, oh, I got to add some more SQL to this thing. I'll just shove it right here. And oh, I got to add some new functionality. I'll throw it right there. It gets bigger and bigger and bigger. Sometimes going back and saying, oh, I updated the same table 10 times in a row with the same filter. Well, I can just combine it all into one update, and it's better. And it will be better. So, very, very quick example here. Basically, this is kind of like before. We have 3 select statements here. We have a select here, where the subtotal is between 250 and 500. We have to join to a table. We're going to select here some different data. Same subtotal, but I think we're selecting same table. And down here we're getting, different data, but again, the same where clause here. So 3 separate selects. This happens all the time in stored procs. We want to get 3 different types of data. So we grab them all separately and do stuff with them. But it's the same where clause. You can just put them together, and granted, this select here is a little more complicated because we're getting this, and this all at once, but we're only hitting the base table once. So we actually went through the execution plans. What we're really doing is we're scanning the table once, just once, ignore Microsoft's suggestion here, doing it once instead of 3 times. This is something to keep in the back of your mind in case you see the same stuff over and over and over. I'm not going to spend a lot of time on it because we kind of talked about this bit already. So this is something that is scary. Anybody here use ORMs that generate SQL for you magically, like Link to SQL and Hibernate or some program like that? No, you guys are lucky. I saw a hand though. I saw one hand. This stuff can be scary because you put together this whole data access layer, you put together a business objects layer, and then it creates the SQL for you. But no human being is creating this stuff, and it's dangerous. If you have bad SQL coming from these kinds of tools, you should probably find somebody to gain control. Usually it's stored procs, maybe functions, views, anything. Because when machines write SQL, it eventually gets ugly. Beware of queries that pull too much data. Again, machine pulls SQL, it pulls data, it may not do its best. Something to keep an eye on. Wherever your company is talking about using an ORM to simplify development, red flags should go off. Chat with them. Make sure it's doing the right thing. Again, check what your where clause is doing, because when you write SQL, you can pick the where clause. When the computer writes SQL, well, I don't know what it's doing. It may do that whole views joining views thing and pick the wrong column. It may take forever. So some telltale signs that you're not writing the SQL and a computer is. If you see lots of select stars or x dot stars everywhere, it's probably a computer, because generally select star is not good unless you know exactly what you're getting. Full joins, you don't write full joins very often anymore, and so if you're doing lots of full joins, it's probably a human being writing it. Really weird where clause where it's like, this is not null, and it's greater than this, and less than this, and equal to this. Very long, lots of parentheses where clauses. Human beings usually don't write that. It's very likely a machine. Long in clauses with 1,000 things in them are probably being written by code or by automated SQL. Beware. And many nested queries. If you see select stuff from, select stuff from, select stuff from, all the way down, it's probably not a human being who wrote that. Watch out. And again, very unnaturally named aliases. If you see things called like T0, T1, T2, T3, I won't allow anybody to develop code like that has aliases like that. You better have something descriptive, and so it's probably a computer. And kind of the point of all this is that if you see this kind of stuff, talk to the developers, talk to the architects, find out where it's coming from, and see what you can do about it, because it's scary, scary stuff, and you have very little control over it. Yes?
What do you think of entity frameworks in regards to performance?
They can work very well until it gets complex. When your business logic gets very, very complicated, it gets worse and worse. Those data, the business objects become bigger and badder, they have more views, they're more complex, and the SQL gets crazy. And so it's really important, if the logic is simple, it's great. As it gets more complex, though, you may hit a point where people are complaining it's slow, and the only solution may be to take the power away from the ORM and say, I'm going to write the SQL myself. Or talk to them about getting a custom ORM or doing a better job. This is something I'm dealing with at work right now. It's a huge deal, it's complicated, and once you begin using a tool to create SQL a lot, changing and going back is very, very hard. So, no examples here. I don't have an ORM right here to play with, but just kind of a warning. If you see SQL that was not written by a human, that's inhumanly bad, it probably is inhumanly bad. Just a warning. A very, very stern warning. So, indexes. You have entire workshops in indexes, hours, days in indexes. I also have a couple notes here on indexes, kind of set the stage here. Always add an index after sufficient research, because indexes are improve read operations typically. Whenever you're looking for data, it speeds it up, but it's the cost of your write times. Whenever you update a table, you update all the indexes as part of it. So the table is very, very read heavy, indexes are great. The table is very, very write heavy, they might hinder you a bit. So that's something to keep in mind. Management Studio recommends indexes. You probably saw earlier a few times the green text saying missing index. check those really carefully because they might be good, it could be terrible. It could be indexed with 30 columns. Beware. Beware what it suggests. Track index usage. I have a different presentation on DMVs. Feel free to download it. It has tons of info on how to track index usage procedurally. And knowing how they're used tells you what is used and what isn't used. It'll be very, very handy. You have duplicate indexes. SQL Server doesn't know any better. If you have 5 indexes in one column, they're all being updated, it sucks. So if you have things that are redundant, remove them because SQL Server is not going to know better. It's going to still update them all. Look at very common queries known as. You have a query that is being executed all the time, index based on it. If the query runs once a year, you shouldn't write tons of indexes for it. Keep it as simple as possible. It's, frequency of execution is going to really determine the kinds of indexes that you have. Tables should have a cluster index. That is basically telling it how should it be organized logically on disk or on your SAN or wherever. It's really important to have a cluster index in a table. If you don't have one, you probably aren't doing it right. I can't think of very many reasons you won't have one, and so if you see a table that does not have one, research it, because it very well could use one. Cluster index is basically your main key in the table. It's usually the primary key, and it's usually what you'll be searching on and joining on frequently. And if you don't have one, there's a good chance that every join is going to result in a scan, and it's going to be painful. Consider filtered indexes. Somebody mentioned filtered indexes earlier. Filtered indexes are basically, you create an index, just like usual, you put a where clause on it. That is really great if you're always searching based on very specific clauses because your index only contains that and it's smaller and leaner and meaner. For example, if you only want to choose data that's the status of complete, you can say, oh, only include in this index where complete. It can be faster, less reads, less data to look for. And again, they increase writes and decrease reads. So this is a quick query I have here to look for missing indexes. Again, this is Microsoft's suggestions for missing indexes. I'm not going to really explain the query right now. You can look at it more closely later and kind of investigate it. But this query basically goes from DMVs, some really good DMVs, that tell us about index usage. I'm just going to run this whole thing, look at it a little bit more later. But it uses our missing index DMVs, and I get nothing, which is very sad. I got one earlier today, and I have nothing. But basically, this query is going to return data to you about all the indexes Microsoft thinks you should have, but don't have. And therefore, they might be good, or they might be bad. Play with it on your own. You can use it in a test environment. It's pretty lightweight. It didn't return anything here, which is very sad. But I'm going to move on because it's kind of something I want to give you to have as a tool more than anything else. So we're almost there. We're almost done. I have a few more notes before we finish. I know I'm moving very fast, which you may like or not like. Hopefully more of you like it than not. So how to help SQL Server help you? I went through tons of suggestions here, lots of tips and tricks, but how do you help SQL Server work a little better? I've given you a lot of ideas already. Some general things you can do. Foreign keys are huge. If you join in a table a lot, you have relational data, you should probably use a foreign key. And we're not talking about MongoDB or some non-relational sort of structure. We're talking about SQL Server here. If you have transactional data going on in a relational database, and it's relational, I'm using the word relational a lot here, use foreign keys, they help statistics. Because now SQL Server knows that this relates to this, and it can behave assuming that. Whereas otherwise, it can't assume anything. And that's a huge deal. Not null columns. If a column cannot be null, SQL Server does not have to worry about it. It makes easier statistics. A null should essentially mean in the world of databases that something has no value at all. It's irrelevant. Like something not actually relate to anything else, then it's null. And don't make pseudo-nulls. Don't throw -1 in a table, or 0, or blank. Those are not nulls, unless you actually mean them to output that way. Yes?
What about nulls on foreign keys, like I don't have such a thing?
Bingo, that is perfect. If you have a foreign key to a table, but it's irrelevant here, null is perfect. That is the perfect use of it.
It's optional. You may have it, you may not.
Bingo. And null means the absence of. Like, null is like, if I'm not in the room, I'm null, not here. Otherwise, if I'm standing in the back of the room, I'm not null, I'm over there. And a weird example, but again, watch out for using nulls where you don't need them, and watch out for putting dummy data in. Like if you throw in zeros and blanks and junk to your database, that's cheating, and you may or may not really want that. And what is use the best data type? If you get away with tiny int, use it. If you can use a date versus a date time, smaller, that's better. If you can use a bit, always use a bit. If you have a 1 or a 0, use a bit. Do not use a tiny int, don't use int, don't use a big int, don't use a varchar. If it's a bit, if it's true or false, use a bit. Because the smaller the data type is, the less data you got to grab from your server, the better off you are. The varchar 100 will always be good. Don't use a varchar max. Please don't use a varchar max. Max is very big. And it's not stored on the same pages as the rest of your data. Therefore, it's messy. Constraints. Again, I mentioned it earlier. Your data can only be certain values if it should always do something no matter what. Not only do you enforce some business logic here, but the constraints tell SQL Server what's going on. That's very, very useful. Index views. You can create a view, and you can put indexes on it. If it's inner joins only, and that allows you to kind of create some better reporting views or better views to select from. It's a little more complicated to maintain. They're very, very useful for more complicated views if you want them to actually make sense and to select quickly. Statistics, by default, go in all your columns. Indexes get them too. They're wonderful. But if you think the statistics are missing, if we're getting close in time?
Please.
Sure. If your execution plans say you're missing statistics, that's a problem, so add them. And I'm going to jump through very quickly. Configuration settings are important. Check how your SQL Server is configured. Make sure you have enough memory allocated. Make sure your ad hoc workloads, the optimization setting is set or not. That can be huge. This is basically used for when you have lots of very irregular queries coming through. MDOP, very important. Read about it, learn about it. You may or may not need to set it to anything particular. Just make sure you have the right values set. And compatibility modes can have a big deal too. If you don't need them, don't use them because it's basically a liability upgrade. And rebuild indexes regularly. Really, really important. Rebuild them when the system's not at peak usage. Really important. They won't rebuild themselves. That basically, because over time as you delete and insert, this nice beautiful tree of index gets messy. Always rebuild regularly. It will help you a lot. And update statistics too. They do not update themselves. Again, SQL Server won't do these things for you. So these two things here, there is lots and lots of information out there on how to do it efficiently. Definitely do it. I have an example. We're going to skip it though. It's really just showing a few examples of what we've already done here. So, I'm basically done here. A few resources before I finish though. SQL Century Plan Explorer, these are some links here. You can click on them later, go to this presentation, download some stuff, take a look around. This tool is awesome. I recommend it. It takes your execution plan and makes it big and pretty. I like that. I like big and pretty. This book here is a free download. It's deep, dirty inside of the optimizer. If you want to really learn how it works, it's a pretty good book. It tells you a lot of deep information, and you'll definitely learn something. By a very smart guy, Ben Neverez. SQL Saturday, you can download all the presentations going back as far as you want, including this one, and other previous ones I've done, other people have done. Really handy. SQL Pass is their main site. If you want more info on Pass, it's free to join. Professional Association of SQL Server. SQL Server Central, awesome website, immense information. They email out some great things every day that I read and I love, and they're by very, very smart people. And last but not least, thank you very much for coming. I know I gave you a lot of information in a very short time. If you have any questions at all, feel free to chat with me afterwards. It's meant to be a starting point, kind of like the ideas as to where to go and where to begin, how to start your adventure of optimization.